Hello, and welcome to this demonstration of Nethra VideoAnalytic's, massive analytics deep learning platform for analyzing video data. An oft-cited study in the monitoring industry concludes that after 12 minutes of continuous video monitoring, a person will often miss up to 45% of screen activity. After 22 minutes, up to 95% is overlooked. In today's digital world, where we capture millions of hours of footage every day, the demand on operators is too high to rely on manual viewing of video feeds. As we'll demonstrate, Nethra has the capability to automatically detect a multitude of different events in real time from video feeds, drastically reducing the demand on manpower and delivering quicker and better outcomes. First, we'll be showcasing how Nethra can track and count crowds of individuals in a busy subway station from multiple video feeds. A powerful tool in a variety of use cases such as crowd management, people movement analytics, and security. Second, we'll present our augmented reality model of St. Pancras Station, allowing a 360-degree view of people movement and crowd density, enabling live management and event detection of busy public spaces. This first dashboard shows 6 streaming videos augmented with what we call our head model and path results from the Beijing subway. The red boxes represent the head model results, while the other colored boxes represent the tracking of these across frames. The tracking result, e.g. a person's path across video frames, is represented by the colored lines following the boxes. From the tracking result, we're also able to tell whether it is a man, woman, or child. The blue lines are what we call lines of interest and are added to each video camera setup. These may be on particular gangways or entrances, etc., and can be at any angle. The lines of interest are the focal point for the video analysis. Drawn on these lines of interest are counters showing the number of people crossing the line, based on the head tracking. You can see numbers for the number of people crossing the line as either up, down, or left-right total figures. All statistics, including head positions and unique identifiers, can be streamed in real time as raw data and will work on a live video feed from an IP camera. Each video shows a slightly different scenario in terms of crowd entries and exits and demonstrates the head model's ability to cope with various issues. Some of these issues include people being reflected in walls and railings or as shadows on the floor. Multiple exit entry points can be covered in a single video. For example, video 6 shows people moving to the right, either from a stairwell or an entrance on the top. It can also cope well with sudden changes from static to dynamic movement, as shown in video 2, with people queuing and then boarding a train. As well as tracking movement, these videos also demonstrate Nethra's coat color matching capability. Each box contains a color swatch matching the coat or jacket color of the particular person. This capability has many applications. One example is in security and policing, where it could help identify a suspect or perhaps alert station staff to large groups of sports fans. Nethra can also detect whether people are carrying bags, and with a little more development, this could be expanded to recognizing particular brands from their shopping bags on a busy high street for marketing or advertising use cases. Where this becomes really exciting is when we combine feeds to get a clearer understanding of real-time people movement in a space, whether that's a train station, airport, or even a busy street. Taking this concept to the next level, we've modelled the St. Pancras International train station in London. As you can see, what we have here is something very similar to what was shown in Beijing. We have the same head tracking and coat color recognition. However, in addition, we've combined data from 2 camera feeds with a WebGL model to create an augmented reality view of the station that shows people movement in real time. Real people are represented by avatars in real time in this model. This model is interactive, and I can change my viewpoint to look at any angle. As you can see, the movement of the avatars matches what can be seen in this camera here. You can switch between the two cameras using Switch Camera button. Total figures displayed on the meter graphic are arrived at using a wider video of the entire gangway and a separate crowd density algorithm, which allows us to estimate numbers outside of the CCTV areas. People in the CCTV areas of the model have been color-coded according to their jacket color, which has come from their head model video data. By modeling an entire space, we are able to stitch together unique identifiers across CCTV feeds to really get a feel for overall movement, crowd control pain points, and create custom alerts. This dashboard contains the video from camera 2, showing the same area of St Pancras from a different perspective, as well as a wide-angle shot of the area. On the right, we have the feed from camera 2. If you look here, we also demonstrate the ability to augment video to compensate for spherical distortion, which gives us accurate numbers to feed into the model by turning the floor tiles into squares to provide a grid system. On this side, we have the crowd density estimator, which is taken using the wide-angle shot. This is separate to the head model and can be used to give an accurate number of people in shot at any given time. This is also the number we have represented here on the gauge meter. This package focuses on counting individuals, but it also includes some of Nethra's other functionality, such as identifying crowd-like behaviour. On this particular video, these large green boxes represent crowd-like movement, where groups are moving as one. Other Nethra capabilities, such as identifying fights, can also be included, with the corresponding alerts, for a comprehensive solution to managing busy public or private spaces. With custom alerts, management of these spaces can be smarter and quicker. This demo was just a brief overview of one use case and some of Nethra's capabilities. Contact us for more information.